All right, this is our first lesson for Intro to IM, lesson 1.1, prime factorization. We're going to be breaking down numbers into smaller parts to discover all of its factors. So let's start with some vocab. A factor is a whole number that can divide evenly into another number. Before I go any further, just so you know, pause the video at any time. If it's going too fast, just pause it so that you can write down what you see. Multiples. Multiples are what you get when you multiply a number by other whole numbers. So for example, the multiples of 3 are 3, 6, 9, 12, and so on. A product is an answer to a multiplication problem. So if I said the product of 2 and 5 is 10, because 2 times 5 is 10. A prime number. Prime number is a number with exactly 2 factors. We'll go over prime numbers in more detail in class next time I see you. But for example, a prime number could be something like 7, because the only way you can multiply 2 whole numbers to get 7 is 1 times 7. There's no other way. A composite number, on the other hand, is a number with more than 2 factors. So something like 8 is composite, because 1 and 8 are 2 factors of 8, but 8 could also be written as 2 times 4. So we have just shown there are at least 4 factors of 8, which is more than 2. All right, once you have those vocabulary words written down, let's go back to the notes at the top. I have a statement that I hope you all will agree with. 7 times 3 equals 21. So just so you know, that dot here represents multiplication. You may have seen other ways to symbolize multiplication, like maybe an X. But for this class and moving forward, we're going to try to use the dot to represent multiplication. I want you to try to predict what 7 and 3, the numbers written in blue, could be called. I'll give you a hint. It's one of these vocabulary words. 7 and 3 are factors because they are whole numbers that divide evenly into 21. 21, the number in red, is another one of these vocab words. 21 is a product. So there are some shortcuts. You don't have to sit down with your calculator and take 21 divided by 3 and see if you get a whole number all the time. I'm going to show you shortcuts to see if a number has 2 as a factor, 3, 4, or 5. Let's go one at a time. So you can tell a number has a factor of 2 if the last digit is even. So in 7,326, that's a big number. I don't want to deal with that whole thing. I can just look at the last digit, the 6. Notice that it's even. So 2 is a factor of 7,326. Here's the shortcut for 3's. If the sum of the digits of a number is a multiple of 3, then 3 is a factor. So the number 7,326 has 4 digits: 7, 3, 2, and 6. And the sum of those digits is what you get when you add them all up. 7 plus 3 plus 2 plus 6 is 18. 18 is a much nicer number to work with. Hopefully you can recognize that 18 is a multiple of 3. So 3 is a factor of 7,326. Here's a shortcut for 4's. It's similar to 2's, but instead of just looking at the last digit, you look at the last 2 digits. So here's the last 2 digits of 7,326. Is the number 26 a multiple of 4? Does it equal 4 times a whole number? No, it does not. If I put 4 times 6 is 24, which is too small, but 4 times 7 is 28, which is too big. So we can say that that doesn't work. 4 is not a factor of 7,326. And then the one for 5s, hopefully you may know it already. If the digit is a 0, the last digit, if the last digit is a 0 or a 5, then it's a multiple of 5. And 6 is not 0 or 5, so 5 is not a factor. Okay. We are going to be asked to find the prime factorization of given numbers. And there's a couple different ways to do it. One way is what I like to call the birthday cake method. If you take 175, we'll start with this one here, and we divide it by a prime number. That's the trick to the birthday cake method, is you have to pick a prime number. So I noticed that 175 ends in 5, which is prime. So I'm going to use 5 and divide it. When I do, I will get 35 as my my quotient, my answer to this division problem. The next thing you're going to do in the birthday cake method is ask yourself, is 35 prime? No, it is not. It can be divided further. So what's another factor that goes into 35? Well, 5 works again. 5 times 7 is 35. And at this point, we can ask ourselves, is 7 prime? It is. So these are our prime factors. And if we multiply those three numbers together, we will get 175. So the prime factorization of 175 is 5 times 5 times 7. All right. If you like the birthday cake method, you can continue that for 235. But I'd also like to show you another way, arguably more common, more popular, I guess. There's a factor tree method. So you can take the number you start with and draw 2 branches. And in this way, you don't have to choose prime numbers. You can think of any 2 numbers that multiply to 235. So again, I saw a 5 there. I'm going to use 5. And then you can use a calculator if you want. Do 235 divided by 5. We should get 47. When we do that, we need to check each factor and ask ourselves, is it prime? Well, 5 is prime. Is 47 prime? It could be 1 times 47, or could we write it a different way? And actually, no, we can't. So we are done. The prime factorization of 235 is just 5 times 47, because 5 and 47 are both prime. All right, use either method, birthday cake or factor tree, to find the prime factorization of these 2 numbers, and then come back and check your work. All right, there's the prime factorization of 344. I used the factor tree method this time. And here's the prime factorization of 256. I used the birthday cake method that time. One thing I want to point out is that for 256, we have 1, 2, 3, 4, 5, 6, 7, 8 factors of 2. So you can just write 2 times 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 2. Oof. But if that's a little tedious, you can use exponents. You can say there's 8 factors of 2 multiplied together, so that's just 2 to the power of 8. That's it for the first page of notes. I do want you to cross out the word summary, and instead, when I see you in class, we're going to write a list of the first 25 prime numbers. Just for your reference, I'll give you a hint. 2 is the first prime number. And then if you want to continue that, you go ahead. Otherwise, we can continue this in class in person. The next page is a page that you do not have to do. You'll find that almost every lesson in your notebook has practice after the notes. You don't need to do them unless you see me do them in this video. And we are going to do a few. We had prime factorization examples in the video a little bit earlier, so hopefully this makes sense that the prime factorization of 30 is going to be 2 times 3 times 5. You could write it 5 times 3 times 2, but generally you want to write the factors in increasing order. So there's the prime factorization of 30. And that is different. That's a different problem than when you're asked list all the positive factors of each number. So I want to show you what that would look like. If we have the number 30, and we need to list all the positive factors. You really want to be careful that you don't miss a factor. So let's start with 1. Every single time you have a problem like this, start with 1, because 1 is a factor of every single whole number. And it should be pretty straightforward. 1, whatever the number is, 1 times that number equals that number, right? But then we're going to just go in order. The number after 1 is 2. Check. Does 2 go into 30? Yes, it does. It's 2 times 15. Or how about 3? Does 3 go into 30? Oh, I used X's. Let's switch over to dots. Yes, 3 is a factor. It's 3 times 10. And then how about 4? Is 4 a factor of 30? No, it actually isn't, because 4 times 7 is 28, and 4 times 8 is 32. You're not going to have a whole number that you can multiply 4 by to get 30. So we just cross it out or erase it, but the important step is that you are actually thinking to yourself, is 4 a factor or not? Move on to the next number. After 4 is 5, and 5 is a factor of 30. It's 5 times 6. The number after 5, as we go down, would be 6, and that's where we can stop. You know you can stop when the number you write on the left side is already a factor on the right side. So we don't need to continue. We've listed all the factors. And we're just going to write them out. It says list all the positive factors. So the factors of 30 are 1, 2, 3, 5, 6, 10, 15, and 30. And that's how you would answer a problem like this. You might see something like that on Khan Academy. Last one, I want you to try this one on your own. List all the factors of 28 and then come back and check your work. There we go. We should have 6 factors of 28. 1, 2, 4, 7, 14, and 28. Again, make sure you're checking if 3, 5, and 6 are factors, but you'll find that they aren't. That's it for lesson 1.1. I will see you all in class.